Yes. Welcome again to today's episode. We want to design a PET bottle, water bottle for the blow mold. 1 liter bottle. We see if we make 1 liter or exactly or less than 1 liter. We want to confirm with the water that we are using, that's 1 liter destination. We want to look at how much normally it has. So let's start with designing. First of all, we can make the neck piece. Let me check the neck piece. I can make it 24. Let's start. So front plane, new part. We are going to use solid modeling. On the front plane sketch, we take a midpoint line, draw a midpoint line all the way from this. The vertical, you can make it for construction geometry. Want to take this height, want to make a height of 270, for example. Let's make this one 270. Press F, that is fit to normal. Zoom this area, take a line from here all the way like this, draw it vertically, have this part. Again, you have this part. You want to draw the whole bottle in this part like this. Want to take this part, let's take this part as 25, height 25, all the way from here up to here. Let's make it 25. It's not bad. This one we can make it 1.5. Same to this one as 1.5. This one we can make it 24. Let's use 24.3. This 24.3 stroke 2. This one we can make it 28, so we can make it 14. This one we can make it 33 stroke 2. Here you can make it 4. This one, sorry, remove this one first. This line, this one, and this one, make it collinear. Hold down Control, make it collinear. Then here you can make it 4. This one, make it 4. I want to check from here up to here. We can make it 18. We want to check. I'm using the defined dimensions to make it 18. I'm using predefined dimensions. Okay, and then zoom again, come here, down here. I want to start it down here again. I want to use the actual dimensions for this bottle. I want to see if indeed you will make it, if indeed we will make it what we want. That is to be 1 liter. This one, put a point somewhere here. There's a reason why I want you to do that. My dimension from here up to here, put it 12, for example. 12. 12. We want to see this part. You can make it, that is 50. Then this part we can make it 72. So take a line from here all the way to this point, like here, like this. Make it horizontal like this. So maybe we can make this one horizontal, this point, sorry, this point, and this point, make it horizontal. Hold our control, select these 2 points, make it horizontal. I want to make from here up to here, I can make it 25. From here up to here, maybe 35, for example. 35. I want to go up. How much? Maybe this can be 30. Let me take this one from here, like this. Maybe from this point up to here. Let me take a line first. Make a simple straight line like this. Then this one and this, you can make it tangent, like that. So that here you can make it somehow 10. This one we can make it 10. But from here up to here we can make it something like 30, for example. 30. Want to check on this diameter. What is the diameter here? I want to put the actual diameter. Yeah, we can put it somehow 80. We say 40. From here up to here we can keep it 40. We'll come here to check this one. I can change it to 10. Then give a fillet. From there we can go enter. This one give it 79. Can go inside. Then we go somehow like we can make this one something like, say, let's go inside a little bit like this. Then make it vertical. This one we can make it 68. That is 670, say 79 stroke 2. 79 stroke 2. Then you can assume from here, from here, this point up to here, can give it 68. Press F. Check the distance here, the angle here. Yes. Make it smaller. And from here up to here, I can make it 1. Like this. Okay. And then from there, we want to come back this region. Take a curve from here, like this. Yes. Want to see this. What is the maximum diameter at this point? Let's take it also 78. Here we can take this one as maybe 50. From here up to here we can be taking it 50. F. Zoom this region, this region. I want to put this one up to here. Can give it 78 stroke 2. want to see this one. So I want to make it smaller first of all. Move this one because it doesn't look like a good design. This one and this one, make it coincident like this, and then come down here again. Want to make this part, this part comes like this. Okay, make this one and this one as tangent. Take another 3D point, 3-point arc. I'm using the simplest commands, drawing arcs like this, the example like this. I want to make it simpler. This part, I want to make it simpler from here like this. I want to make this one and this tangent, then maybe from here up to here I can say horizontal. My dimension this part from here up to here. Let's put now 50. See, then you can say this point and this point, maybe this point and this point can be vertical. This, you see, the bottle is already fully defined. Yes, the sketch for this one is fully defined. Then you can put a simple fillet here, and this one can put 2 or 5. Let me use 5. 5, not bad. Okay. Now, depending on when I want to put 2 because of the neck piece. I want to put it too big because of the neck piece. Okay. And then also this part. Why did this part go inside? I will tell you later. I want to understand why I put this one to be inside like this. I'll tell you later. Don't worry. Okay. So once I have done this one, I want to fillet. Yes. Yeah. Fillet where the sharp edges. Fillet 2 where the sharp edges. These are point of weakness. Okay. 0.3, 0.4 point of weakness. Minimize point of weakness. This is 0.3. Okay. Where else? Then you come here. What else? I've closed it. So this is I'm using solid modeling. So come to Revolve Features. Say yes. Then click here. Okay. So we have our bottle design. If you check, we have a bottle design. It is now solid, but you want to check how much volume it will have. Maybe let me change the material of my bottle. It is solid. I will show you how we can measure. Let me use plastic PET bottle. I'm using PET. Click apply, close. So this is the water bottle I have. I want to remove sharp edges first. So I'm gonna put like 5. Okay. These places. Yeah. Yes, like that. So this is the bottle I have, control 1. I've designed it using solid modeling. Yes, solid modeling. But let me solve this one first of all. 1 liter bottle PT like that. So I want to check the volume the way it is solid, because I've definitely used solid. I want to see the difference. So for you to check the volume, it is the way it is solid. Come to evaluate. If evaluate is not here, put a pointer here on feature manager design tree, right click, then go to tabs. Here take you can check what you want. You see that, for example, if I uncheck this one, it will go off. But if I place again here, come to tabs, I click on it, it will come on like this. So go to evaluate, then click mask properties. Recalculate. It will give you the volume here, which is a cubic millimeters. How many liters make a how many liters make a cubic milliliter? We have 1000 milliliter equals to 1 liter. So 1000 times 1, that is a cubic, that is 0, 1, 3. So this is the 1 point, this 1 point, this 1.0 liters, yes. This 1.0, that is 1 close to 1 liters, yes. We can check. So this is close 1 liters, yes. Come here also, you can check the detail sections. Come to document properties, units. You can change the units. You see, these are the are using this. You're using that is millimeter, gram, second, or you're using inch, pound, second, or you're using, or you can customize yours. Which unit are you using? You can also customize, but remember here the custom one. I can customize mine. You don't have for length, only have millimeters for the length, yes. Then angle, degrees, you can change maybe the mass here also. It is milliliters, centimeters, so we don't have okay, we can change liters. Let's change liters. First of all, for the volume, let's change to liters. For the volume, liters. We can check how much liters our bottle has. Click OK, and then come to rebuild here. Click rebuild. Come to mass properties. Check how many liters you have. You see, it is 1.06 liters. So this bottle holds 1.06 liters. But is it the actual volume? Okay, I've done it solid. Why? Okay, what do I do, or what is next step? I want to shell it first. Let me shell it to a thickness of 1.5, for example. 1.5. Maybe I click on this, then show preview. Where it will not shell, I'll show you why. Normally, when you're pouring water, some people normally put it to the brim, because not like juice, you cannot fill the juice up to the brim unless you need to know the actual volume it has. Most of volume may reach somewhere here, going downward, or even somewhere here. I want to check this one first of all. My shell, I've done the shell. Now I've done a shell of 1, that is 1.5 thickness of 1.5, but that is too big. Yes, let me check. You see, if I do section view, I'm able to see my design here. Yes, this point, I'm able to see my design here. But let me also check the volume again after shelling. Mass properties, you see, the volume is 0.1 liters. The volume has reduced, which means the content has changed. What if I change this to 1.2, for example? Okay, I just accept 1.2, and then let me check the mass property again, 0.08, to see how it is telling me. So it is not telling me actually volume that I want, but if I remove the shell, then I click on mass properties, it will tell me that the volume is 1.06. Okay, how do I ensure that I give the actual volume for this? I want to do something here I want to put this shell in now, and then I want to offset a plane, for example, plane, let me say this face, for example, I want to put it like 5, offset 1, is it? Okay. I want to, let me put 15. I want to assume that when I will be pouring water, it will reach somewhere, let's say, first of all, let's use 20 or 25. Okay. Let me put 20. First of all, 20, 25 is down. I want to use 20. First of all, let me use 20. So I'm assuming that this plane will define my where I'll put my water. Okay, I'll fill in the water. I want to check something here. I want to, there's a feature I want to use intersect, this intersect, and then I want to use this plane. So here I need to pick the plane, so I can pick the plane I've made, this plane, yes, and then I want to create intersecting regions, see, or inner regions. So I can create inner region because this one is hollow. Remember, if it was solid without shelling, it was giving me 1.06 liters. But if I proceed to create a region, maybe intersecting region, using this, for example, I don't want to use intersecting region, see? I want to use create internal region. For example, then let's say intersect. I want to create internal region. This one is meaning I want to create volume inside. I want to create volume inside the bottle. Okay. I want to click on this one. I want to see. You see, this is the region. Then the upper one I will show you why. Maybe, for example, I want to click this. What did I do? Let me show you this. You see, let me repeat again for the sake. Initially, was my design. When I try to check the volume here, mass properties, it is telling me it is 1.06 liters. Because now it is solid. It was solid. So which means it is assuming that there is content inside up to the brim. But remember this content, it has even taken the volume for the wall. But when I did shell here, I checked my properties, the volume came to 0.08. The shell was 1.2 millimeter thickness. Then here it is giving me 0.08 liters. Is it what I want? No. Okay. Next is I took a plane from this face. I'll put a plane down like let's say 20 millimeter. Okay. And then from there, I came to do what you call intersect. Go to features, this insert. Let me remove this. Insert, features, then intersect. So in this intersect, if I do edit, I took the plane that I made. I want to assume that I want to create internal region. I want to create something inside. So once you say plane and then you pick this part, the shell part, now as was now shelled meaning inside is hollow, then I say create internal regions. So I want to assume that whatever I'm creating inside is my content. But where will I fill it? Maybe, for example, if I'm using water, I'll fill up to this region, where the plane is. If I click Control 1, where the plane is. Here. So this is where I'm filling. You see, remember, you see up there. So this is the internal region. This is the wall. You see the different colors. This is the wall, and then this is the internal region. Meaning, I'm assuming this internal region is the water that I've created. If I click OK, I want now to go to mass properties. You see, mass properties, it is not measuring the upper region, it is measuring the lower region. It's not measuring the upper region here, it's measuring this lower region, which means now my volume until here it will be 1.05 liters. If it is water, for me it's okay. But if I'm using something like juice or milk, those are usually, remember those are demand high-end products. So I cannot tell my client that they fill up to here because it will be too high. So somehow I can maybe change the plane here. Maybe, for example, I can change the plane to 25. If I don't want to change the design, 25, for example. And then here, I can just say edit, then okay. Yes, edit, okay. You see, here, it will not tell me because it is giving me the problem. So if I click here to rebuild again, rebuild, you see it won't accept, which means I need to again remove the plane. If I say delete, maybe for example I need to delete this one, intersect, come to insert features, then come again intersect, then I will take this plane and this shell, then I say create internal region, then I say intersect. If it intersects again, give me a new region. Yes, and then I come to mass properties, I check the volume is 1.05. So this one we may do a try and error until it gives you the what you want. But remember, this one will take you a lot of time. So somehow maybe I can change the design. For example, let me come here. I want to look at these features. Maybe, for example, what I've put here. Maybe I can put this one as 12, for example. If I want to change this as 12, then I exit. Yes, I exit. If I come here, I rebuild, then mass properties, it is telling me still it is this amount. You see, this one will give you a headache of designing your model. But it is good to know how much content you are going to fill in. Maybe I can come again, change this. So you were able to do try and error, changing features here and there so that it suits the outcome for you, your volume. For water, for me, it's okay. For water, it's okay because that's where I can feel it. The water is okay. Yes, but if it was milk or juice, this one won't be okay for me simply because it will be too high. So somehow for you to measure the volume of this is the key procedure you're able to use. You can now go ahead to change the dimensions. For example, if I was using, let's say I was using, you see this one, if I increase, if I was using Creo PTC, I'm able to calculate using equations to give me this part. Also in SolidWorks, you can do that one for advanced cases. But for you, I don't want to go much into detail. But how do you measure the volume of this is, if I'm using this one because this one was a PET bottle, I want to check the volume of this is just design your bottle. This one is put the shell. Once I put the shell, I offset a plane somewhere. This plane, I can now create an intersect. This intersect will be able to help me to know the volume here. This is the content inside, and then this is the upper region. I'm able to know the volume of my content. If I okay, click on now evaluate mass properties, I'm able to give me that the volume of this is 1.06 liters. But how do you come about this one? Remember, somehow units here, you need to understand how to change the units so that you're able to know in liters without you again calculating or computing. Here I'm used because we have the mmg, ips, mks, centimeter, kilogram second, centimeter, gram second, millimeter, gram second, inch, pound second. I've used a custom one, and then I went to the volume. I changed here to liters so that I can change direct when I come to evaluate mass properties. It will be able to give me that my volume is in liters. So this liter is 1.05 liters. So I can put my design, I can change maybe design one by one. Maybe, for example, somehow I can reshape this one. I try to change the parameters to suit um, what I want, one by one, until I have the actual figures of my design. Maybe this one I can put it, let's say 265. Yes, I'm able to change this height. Yes, one by one. If I go ahead, because I've already done in the intersect mass properties, now you see the volume is changing to 1 point this. So you somehow you can change the parameters of your design. Maybe if your design is too high, you can change your design so that it suits what you want, one by one, until you get the actual volume that you need. You see now it has come to 1.03. So for me now 1.03 is okay, because I am able to dictate my volume somehow here. You see this volume, I can say now volume, maybe I want to change the plane. If I remove this intersect, yes, I've done a shell, I can edit this plane. Say I want it to fill to 20, then I click OK, come to insert features, and then intersect. I will pick the plane here, this plane, and then shell, then say create internal regions. So in create internal regions, then click intersect, which means whatever I'm creating inside is the water. If I click here edit, I want to assume that my content will come up to this region. My content will come up to this region. This is how um, I've done my design. If I click on our mass properties, you see now the volume has changed to 1.02 from 1.05. So you were able to do this one many times until you get the actual volume. As I said, our main purpose was to design a 1 liter bottle. So how do you design a 1 liter bottle for water? PET. And how do you measure the volume of your design to ensure that whatever is going to fill in will fill up to what it is supposed to fill. When you check the mass property here, we're able to know that now our content, according to where it is, it will have our volume of 1.02 liters. 1.02 liters is okay. If you happen to measure the actual volume of the bottle they have actually for let's say for 20 liters, it's not normally 20 liters. Actually, I think I've tried to check most of this 20-liter PET bottles. They are normally 18.9 liters, which is not 20 liters, which means they somehow the actual volume is not correct. So when you're designing, don't steal, yeah, and don't lie. Okay, there's some aspects that we normally maybe we can check things like shrinkage factors, but when you're designing, you need to ensure that you factor in shrinkage factor and all other features in your design. This is said, so we want to go ahead now. Um, I want to go ahead to do more of support features. Support features. This is what our bottle has, but I want to do support features on this one so that our bottle will be strong. So come to front plane, sketch. I want to use simplest method. Um, Simplest method here. I want to use simplest method, convert, then change here to this part, zoom this region. Okay, then click this one, click convert entities, this one, convert entities, then change one for construction geometry. For construction geometry, I want to put support so that our bottle will not be weak. Yes, then we can take a line maybe from here. I know this line may not go the way we want. Click somewhere here, then change this one to horizontal. Maybe from here up to here, you can put it 15. Okay, take another line. I want to show you how you can put support in your design. make this one horizontal. Yes, from here up to here, put it 15 again, sorry. It has gone at the center, no problem. No problem. I will show you how to remove it. It's already fully defined. From here up to here, put it 20. I want to use 20. I don't want to put too many of them. Let me put 20. 20. Okay. Yeah. Then take this one, draw a line. Draw a line from here up to here. Bring it like this. Then say this one up to here, and this one, hold on control, say tangent. Another one from here up to here like this. Then hold on control, this one and this, say tangent. I think we can put 3 of them. 3 will be good. So this one, make it horizontal. Smart dimension, maybe from here up to here you can put 15. You can even also make this one to be 15. 15. And then I can move this one. I want to put from here up to here as 15. Yes. Then take another 3-point arc from here up to here. Make this one and this as tangent. Maybe we can add another support here so that our bottles will not be weak. From this one up to this, make this one be horizontal. Smart dimension from this one up to here as 15. 15, take a 3-point arc. 3-point arc, join from here up to here like this. Then hold on control, pick these two, say tangent. Tangent. Sorry, not it should be tangent. This one, and this. Hold on control, pick this and this one. Then say tangent, tangent, and then change these lines to be for construction geometry. These lines for construction geometry like this. And then change this view here. Change the view here. There are many methods. Then come to features, curves, split line. Click on this face, then click OK. You see what we have. Then we can come to sketch, 3D sketch, convert entities. You can pick this one and this, for example. Click OK. Then exit, go to features, come to curves, composite curve, already picked, click OK. So you have one composite curve, then come to sweep cut, pick a circular profile, then the diameter for 2 should be 1.2, 1.5, sorry, 0.5 to be small. Support, pick this one, it should be 2, okay. Then click OK. You see, if I zoom here, I have this part. Yes, this part. So this is support. We can do the remaining like that. Let's convert entities. Pick this one and this. Okay. Exit. Go to features, curves, composite curve. You pick this one. Okay. Come to swept cut, circular profile, put it 2. Then you pick this composite curve. Say okay. Come to features, sketch again, 3D sketch. Click on convert entities. You click on this one, this one and this. Okay. Exit. Go to features, curves, composite curve. this one. Okay, then come to features, swept cut, circular profile. You push to pick this one like this. Yes, you see how we are making our design now to have support. 3D sketch, click and convert entities, select this one and this. Okay, exit, features, curves, composite curve. You pick this one. Okay, go to feature, swept cut, circular profile, put 2, then you pick this one, then you click OK. Very simple. Then you're able to zoom in now. You see, you can hide this one, these ones. Yes, you can hide the composite curves. This composite curve. Then you can fill it maybe 0.5. Yes, zoom in this region like that. You can fill it this. You can fill it this. See, prevent sharp edges. Yes, to prevent sharp edges. Okay, that is how we're able to put support, because remember the PET bottles will be weak. You see our feature, our pattern, how we have put our pattern. I want to do another one sketch, simple pattern. Yes, maybe take a line, midpoint line. I want to change the views. This, maybe for example, somewhere here, make it horizontal like this. Then maybe I can dimension. I want to make it somewhere this like 10. Yes, 10. This point and this point, make it vertical. Then exit, Control 7. This part like this, selected. Go to features, curves, split line. Click on this face. Then okay, you see what we have. Then 3D sketch, this one, convert, exit. It is one sketch, so I can either use composite curve or leave it because it is one line. See, one line. Then I can come to swept cut, circular profile. I put 2, then I pick this one, then I click OK. As simple as this, you're able to create these patterns in your design. You're able to create that pattern in your design. But I want to do something different apart from whatever you have done. I want to do a different pattern. Yes, I want to remove this one. Maybe, for example, I want to edit the sketch. I want to edit the sketch like this. Then show this one. I want to bring this one here to touch this surface. Then make it for social geometry. Then I make another one. Maybe can come somewhere here like this. Make it for construction. Make it to horizontal. Maybe this one I can attach to this like this. Same way to this like this. Then I can say from here up to here I have 15. I want to do something unique. Then this one for construction geometry, take this one from here up to here like this. Then another one from here up to here like this. Yes, or I can do the opposite. or I can do the opposite. Yes, I want to finish this like this one. Okay, then this and this, make it tangent. Same way, do this and this, make it tangent, and then make a fillet maybe of 15. This one and this, I want to put it 20 like this, and then we show this exit. Yes, you see what I've created, the pattern. This is the pattern I've made. You see the pattern I've made, very unique. Come to sketch, 3D sketch, you click on this one. You see that the face, convert, pick this one, the line, not face, delete that. We don't want the face, we want the sketch, only the sketch. We only want the sketch. So this, then click OK, exit, go to features, curves, composite curve, then OK. Then come to swept cut, circular profile, put 2, pick this one, and click OK. Then I can now hide this. This one I can hide. Then fillet 0.5. I pick this one. These edges, then this edge, like that. Then click OK. Yes, this is the unique design I have done. Yes, as unique design I have done. You see, if it was for blow molding, I will use preform for the upper side, this preform. But if I wanted to do the injection mold, I can add the upper one. So let me add the upper one where we can hold, say 2, flip, okay. Then on this plane sketch, click Control 7. Let me show you how we can maneuver. Click on this one, then convert. Then from there, come to features, curves, helical, Control 1, show you. I want to use the simplest one, simplest method, or pitch and revolution. So reverse, how many? 2.2, start angle 0, pitch of 4, pitch of 4, see, so 1.8, it is okay. Then click OK. Control 7, I'm able to hide this plane. Can come here again, plane, can pick this one, curve, then this one here, click OK. Here, I say sketch, for example, I want to sketch something, maybe like this, like this, this, maybe can zoom here, can take line like this. This one should be vertical, maybe. Let me put it here, like here. This and this. Make this like this. I want to dimension this one up to here. Yes. 1.5. I want to say this part and this part are equal. I want to use the simplest one, equal. Yes, from here to here 1.75, that the height here 1.75, yes, then the fillet 0.2, this place, this, yes, and one, okay, and then exit, Control 7. I want to use the simplest one for the case. Come to swept boss base, then you pick this, then you click OK, like that. And this one you're able to hide. I can hide even this. Yes, you see we have our design. Control 5. You see, if I'm able to zoom here, this is what I got. So it has gone this way. So maybe if I feel it's too big, I can change the sketch here. Change the sketch because it should be not too big here. 1.5. This one can be 0.2. It's not be too big. Then exit. Yes. Control 7. Can put a fillet maybe here. 1. This is 0.3. Fillet also down here. Okay. Yes. So we have checked our design. We want to see again the fillet. This face. Put this. First one is okay. For example. So let me leave it for now. For this case. So we have our simple design. We have our simple design. We have done our simple design. Yes, for the 1 liter bottle. The way you see it, we also went ahead to check on the mass properties, like the volume. You see our volume is 1.02, which is 1 liter. 1 liter. And this one, if you are filling 1 liter, it will be enough to fill up to this region. To be enough to fill up to this region. Depending on this plane, I think this is a plane. If you fill in up to, if you are using 1 liter, it will be up to this region. And this is our simple design for 1 liter bottle with different shapes. These are the support because the bottle may be weak. And then in this region where you can put your sticker, you can put your sticker there. So maybe if you are designing for a company, they can put their sticker here, and this one will be a unique design. And then the other features down here, I cannot put. Once the client tell me he wants the features down here, I will also put the features down here to support the design. So this one I've done a template in case the client wants a water bottle. Now I'll put the support down here. If the client doesn't want the support there, I'll remain this one, or I can change the support. We have used solid modeling, not surface modeling. So next phase, we will come again to do on design using surface modeling, and then we'll now create a mold. So this part I'm saving it for the mold work. So we'll come again to create our mold for this part. So I've done a simple design. So this part, the way it is, I did put a plane, which means my content will fill up to this region. Yes, my content will fill up to that region. So this is how we're able to design our bottle. We in SolidWorks I've put majority of the features using solid modeling, where we have learned how we're able to design, check the volume of the bottle. This one, remember, it is, as I said, it is not what I intend to do, but if I was to design it for a client, this shape should also correspond the thickness inside, because the way it is, this part will be weak. So in case the client now wants, I'm able to change this one. I'm doing it for the sake of training, but now if the client wants to understand the actual design, now I'll change so that this shape can also correspond inside, because the way it is, this point are weak point. These are the weak point. It may not be strong as I want. I only wanted to show you how we can put these support features on this. But it's good you put them, all of them, before you do shell, if you're using shell features, so that it will have a uniform thickness all round from up to the bottom, to ensure that the bottle is strong. You don't do it after you have done a shell. So don't ask me questions, say why this part is looking like this. As I said, this is for demonstration purposes. I'll change the shape. I'll use the same shape, but I'll change these features so that it have uniform thickness all round, to ensure that this part is not collapsible when we are doing molding. Thank you for following. Follow us, subscribe for more updates and more ways of designing PET bottles in the next session.